Okay, so this is our third lecture on trigonometric functions. Okay, guys, from here onwards, we will be starting with few basic trigonometric identities. Okay, but then we will try to look at many other identities which are based on the starting, I think, 2 or 3 identities. Okay. Now, today, try to pay attention and then understand as many of these identities as possible. Okay, and I would also suggest once the class is over, uh, in your notebook or maybe on a piece of paper, try to derive all these identities on your own again. Okay, and then later on, when we do problem solving sessions, to help you, let's say, retain these identities or understand how these identities came, we will do plenty of problems practice. Okay, so these are very important. Okay, we'll start with the basic one. Okay. Okay, so this is kind of fundamental, okay, to all the identities that we are about to derive today. Okay, and you should also read CBSE textbook because it's extremely well written there. Okay, so what did we see? I think we saw 2 other identities. So if the input becomes negative, okay, so sine of minus x, we saw this to be minus sine x, and for the cos function, if you supply minus x, it is as good as supplying just positive x. Okay, so I hope you remember these two. Okay, so together with these two results, we should be able to derive cos of x plus y is equal to cos x into cos y minus sin x into sin y. Okay, so note here, we are supplying input, which is, you can say, addition of 2 separate inputs. And then that will result into evaluating, let's say, on each of these inputs, okay, with the help of cos function first, and then with the help of sine function. And then you are multiplying whatever outputs the cos function provides, you're multiplying them. Whatever outputs the sine function provides, you're multiplying them. And then you're taking a difference. Okay. So this is useful. Okay. So right now it is very difficult to say why this is useful, but as we move along, we'll see that this is extremely useful. So we will first try and understand why this is true. Okay, so why cos of x plus y is cos of x multiplied by cos of y minus sin of x multiplied by sin of y. Okay, so this is the first step. We want to understand why this is true. Okay. Now, to understand this again, we are taking the help of our good unit circle. Okay, so unit circle is very, very important. Okay, for everything, if you try and relate with the unit circle, your trigonometry, understanding of a trigonometry will be very good. Okay, now what is a unit circle again? It's a circle of radius 1 unit. So here I'm showing you few angles. Okay, so there is a point, let's look at these 4 points. Point A is on the x-axis, and the other 3 points B, C, D are somewhere else. The angular position of point B. Okay, so with the x-axis, if you turn, okay, so the OA vector turns by an angle x radians, you're going to get that point B on the circle. And if you turn x plus y, okay, so from OB line, we're turning y radians. So if you turn x plus y, you're going to get this point C. And instead of moving in the counterclockwise direction, if you happen to move in the clockwise direction by y radians, because you're moving in the clockwise direction, so the angle is negative here, you're going to get this coordinate D. Okay. So in the given unit circle, we have these 4 points A, B, C, and D. And again, I have listed the coordinates of each of these points. Because A is on the x-axis, the x coordinate is 1, x value is 1, and then y value is 0. Okay. And if you take a look at B, because OB line is obtained by turning OA in the counterclockwise direction by x radians. So the x value or the x coordinate of point B will be cos x and the y coordinate is sin x. So similarly, you can guess the coordinates of C and D. Okay, so the coordinates of C will be from the reference line. X-axis is our reference line. So if you have to go till point C, OA line must be rotated by x plus y radians. So for this reason, the coordinates of point C are cos of x plus y and then sin of x plus y. Now, to get the coordinates of point D, please note that we are rotating in the clockwise direction. Okay, so the input will be negative. Okay, so we are assuming that y is a positive quantity and minus y makes it negative. So the coordinates of D are cos of minus y and then sin of minus y. Okay, so I'll pause here for a minute. Let me know if you have any questions. So make sure you understand why the cos function and the sine function, based on how the input in radians provided gives the angular positions. You can say it gives the coordinates of each of these points, okay, x coordinate and y coordinate. Okay, so I'm assuming this is okay. So let's move on. Okay, so again, the same unit circle here. Now, observe this, okay, because OA, OB, OC, and OD, they're all radii of this circle. So obviously they're all equal, okay, and they are equal to 1 unit. So this 1 unit could be anything, 5 centimeters, 6 centimeters, whatever it is. Okay, but it's considered 1 unit for us. Now, observe the 2 triangles I have drawn here, triangle OBD. Okay, so if you take triangle OBD and triangle OCA. Okay, so pay attention to these 2 triangles. Again, so 2 sides are already equal. If you see OB and then OD, they're equal, and then OC and then OA, they're equal. Now, if you consider this angle, okay, so this angle COD, okay, so if you take this angle, which I'm representing by a dot, green dot, this angle COD, it's present in both the triangles. It is common to both triangle OBD and then triangle COA. It is present in both these triangles. And what this does is, if you consider triangle OBD, let's say we consider that green dot gives us some angle alpha, let's say. Okay. Now in triangle OBD, we can see that this angle at the center is y plus alpha. Okay. And in triangle OCA also magnitude wise, okay, that minus sign is indicating in which direction we are moving. Okay. Magnitude wise, this angle is still y. Okay, magnitude wise, it is still y. So if I look at the angle OCA, that is also y plus alpha. Now what this does is, if I look at these 2 triangles, two sides are equal. Okay, two sides, corresponding sides are equal, and the angle between them is equal. So if you recall, you had SAS rule. Okay, so from congruent triangles chapter. Okay, so I think in your 9th class, I guess. So this makes these two triangles congruent. Okay, so this is important for our derivation. Okay, so understanding that these two triangles are congruent is an important aspect of proving that identity. Okay, so okay, again, so I'll pause here again for a minute or so. Let me know if you have any questions. Okay, we are just showing that these two triangles OBD and OCA, they are congruent by showing that OB is equal to, let's say, OC, and then OD is equal to OA, and the angle between those two corresponding equal sides, which is magnitude was y plus alpha, so they are congruent. Okay.
So, sir, can we show those congruency by SSS criteria?
What is that, beta?
Can we show that by using SSS criteria, sir?
I think you can, because if you look at the angle subtended at the center, equal chords will subtend equal angles, isn't it? So you can say that BD is equal to CA. Is that what you have in your mind?
Yes, sir.
Yeah. So they are equal. So you're right. We can actually use that too. We can use that too. Yeah. So yeah. So either you can use SAS. Once they're congruent, yeah, all the sides are also equal, right? So they are kind of exact copies. If I take this triangle OBD and then turn it in the counterclockwise direction till, let's say, OB meets OC, then you're kind of overlapping these two triangles. Okay, so they are exact copies. Okay, now, guys, I think the diagram has become small for a reason. Make sure you're able to see everything in that diagram. Are you guys okay?
Yes, yeah, sir. Okay.
Yes, sir.
Yeah, okay. So now, because these two triangles are congruent, okay, so OBD and then OCA, so they're congruent, all corresponding sides will be equal. And then here we are taking, like Om has pointed out, we are taking that AC. Okay, so this AC, you can take it as a chord AC, is equal to BD. And then we know the coordinates of these points. And did you learn in your coordinate geometry 10th class that if you have, I think you all know, right? So if you have 2 points, I think I'll put it here. So let's say there is a point P1. Let's say its x coordinate is x1 and y coordinate is y1. And there is another point P2. Its x coordinate is x2 and then y coordinate is P2. So if you want to get the distance between these 2 points, P1, P2, it is obtained by square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so I'm assuming this is a known result. Okay, so we are using this formula to get the distance between 2 points given their x and y coordinates, okay, to get the proof done. Okay, so now if I square, okay, so if AC is equal to BD, if I square them, they will be equal. Now, what is AC square? AC square will be, because if I square, that square root will not be there. Okay, the square root will disappear here. Now, point C, okay, so point C's x coordinate is cos of x plus phi. Okay, cos of x plus phi gives the x coordinate of point C. The x coordinate of A is 1, so we are taking a difference. It's like getting x2 minus x1 and then squaring. Similarly, the y coordinate of point C is sine of x plus y. Sine of x plus y gives the y coordinate of point C, and then minus y coordinate of A, which is 0, and then you square it. And then now go to the other 2 points, B and D. Now, the x coordinate of D is given by cos of minus y. X coordinate of B is given by cos x. So we are taking a difference and then squaring it. So similarly, if you look at the y coordinates of D, it is sine of minus y. And the y coordinate of B is sine of x. So we are squaring. So now once you write that the square of the distances are equal, now you need to just use your a plus b whole square and then open this up and then see what this leads to. Okay. So now, okay, I think I'll pause here. This is important to understand. So let me know if you have questions, guys. So look at it, and then let me know if you have questions. Okay, so I'm hoping this is clear. So let's move on. Okay, now I have put that here because in this slide, I'm just doing the algebra here. Okay, so we have AC square is equal to BD square in terms of the function expressions or function values. So now if I use A minus B whole square, which is A square minus 2AB plus B square, we have here, what do we have? I think I'm repeating it, I guess. It's just repetition, isn't it? I don't know why I'm repeating. Maybe I thought that I did not put this here. Okay, so now look at this, guys. Okay. Or maybe I overwrite. I think I have overwritten. Okay, let's see. Let's see if you understand this. So cos of, maybe I'll write here a minus b whole square. So it becomes easy to understand. A minus b whole square is a square minus 2ab plus b square. So this is what we are trying to use. So what is a here? What is a here? A is cos of x plus y, and then b is 1. So if I square, I get a square, which is cos square x plus y. And this is again something that we need to get used to. Okay, so we don't write cos x plus y whole square. Okay, so when we are taking the square of the function value, we write cos square x plus y. Okay, so that's a notation here. Minus 2ab, because b is 1, we just have 2a. So 2 into cos of x plus y. And you have this plus 1. Okay, so plus 1. So this is till here, I think we are doing that a minus b whole square for this cos x plus y minus y whole square. And then if you look at the second term, okay, so in the second term, you have just minus 0. So there's nothing there. You just square sine of x plus y. So that is put here. And again, on the right hand side, we have to use a minus b whole square. Okay, so if I look at cos of minus y minus cos x whole square, so I have here, okay, now understand this. We have seen that for the cosine function, if you, let's say, supply minus pi by 3, okay, or you supply pi by 3, okay, sine of 60 degrees or sine of minus 60 degrees. When you provide the 60 degrees, you are in the first quadrant and the cos value is positive. If you provide minus 60, you are getting into the fourth quadrant because you are turning clockwise from the x-axis, your reference line, getting into the fourth quadrant. So in these two quadrants, the cos values are positive. Okay, so cos of minus y is cos y. So we have removed this minus sign. Okay, so we have just cos of y whole square minus 2ab, 2 into cos y into cos x plus b square cos square x. So we are done with this. And then we have sine of minus y minus sine x square. Here, for sine, when you provide a negative input in the fourth quadrant, you get negative values. Okay, so that is why sine of minus y is actually minus sine y. Okay, so pay attention to this minus, which is coming out of the function. Minus, what do we have here? Minus sine y into sine x plus sine square x. Okay. Okay, so then what do we have here? Now, if you look at it, we are doing some combinations. Okay, so using the identity that sine square x plus cos square x is 1. Okay, now where do we have the opportunity to combine? So let's look at this. Cos square y, this will become sine square y, right? Oh, sorry, cos square x plus y, sorry, this one. Okay, so cos, maybe I'll put a box around it. Cos square x plus y, and then sine square x plus y, that will become 1. Okay, so sine square theta plus cos square theta is 1. So theta here is x plus y. So that 1 will come here. Okay, and then there is another place where we can, there is 1 here. Okay, so that 1 plus 1 has become 2 here. Okay, so that is the 2. So 1 is coming from cos square x plus y plus sine square x plus y. You already have a 1 here. Okay, so that is 2 here. And then minus 2 into cos of x plus y. Now go to the right side. Okay, so right side, we have, let's say, cos square y. And then you have, if you square, this minus will become positive. So there is a sine square y, so that will become 1. And then you have cos square x and then sine square x, so that will give you 1. So that is where you have this 2. Okay, so I hope this is clear. And then again, on the left-hand side, we are just retaining these things. Minus 2 into cos of x plus y is just retained. Okay, and then these terms are retained. Minus 2 into cos x into cos y, and then this minus will become plus. So that is retained. Okay, so yeah, there is a little algebra here. Okay, so I will pause here for a minute. So let me know if you have any questions here. Okay, so
Can you
I'm assuming
again
this is.
explain it?
Yeah, Harsha, tell me.
Sir, can you again explain it? I didn't quite understand that.
Okay, so from the beginning, you mean?
Yeah, from the third one, sir. Cos square.
Okay, okay. I think we'll do one thing. We'll just go back. So let's go back and then I'll explain. So I think the third box, from the third box, right?
Yes, sir. Yeah, third box.
Okay, so let me do that. Okay, so now here, do one thing here. But you understood the third box, how we obtained the third box, right?
Yeah, sir.
Okay, so now let's look at this cos square x. Cos square x plus y, and then sine square x plus y. Now, what you can do is we are just adding them. Okay, so we are adding them. So it's like getting cos square theta plus sine square theta, right? So here, your x plus y is theta. So then what do you get? You get 1 identity. So sine square theta plus cos square theta is 1. Now you already have a 1 here. Okay, you already have a 1. So that 1 plus 1. Okay, so these two together will give you 1. There's already 1 there. So 1 plus 1 will become 2. So that is the 2 you are getting here. Okay, and then the other term, I did not do anything. Okay, I just brought it down. Okay, so that minus cos of minus 2 into cos of x plus y, we just brought it. So that's the left hand side. Now, if you go to the right hand side, I have cos square y here. Okay, so this will become cos square y. And then here I'm squaring minus, so that will become positive. So you will end up having sine square y here. So these two, if you add, okay, so cos square y plus sine square y, you will get 1. And similarly, I have a cos square x here, cos square x, and then I have a sine square x. Now these two also I will add, and then you'll get 1. Okay, so from here 1, and then from here 1. So those blue boxes, and then I have those purple ovals. So you have sine square x plus cos square x, and then sine square y plus cos square y. So 1 plus 1. So we get this 2. And the remaining remaining terms, I've just brought them down. Okay, so minus 2 into cos y into cos x. Maybe I just wrote x first. Okay, and then you have this again. I wrote x first. This minus into minus will become positive. So plus 2 into sine of x into sine of y. Do you understand, Harsha?
Yeah, sir.
Okay. So now what we can do is we can actually ignore that 2, right? So you have 2 on the left side, 2 on the right side. Maybe you can just multiply both sides by minus sign. Okay. So now that will give you the result that we were trying to derive or like prove. Okay.
Okay.
So are we okay? So cos of x plus y. Now we just eliminated this 2 and then multiplied both sides by minus 1, and then you end up getting, of course, I think I did not say, but yeah, we also cancelled out 2. Okay. So cos of x plus y is cos x into cos y minus sin x into sin y. Is that clear?
Yes, sir. Yeah, it's clear.
Okay, very good. Okay.